Hello. In this video, we're going to learn how to balance simple redox reactions. This can be more complicated than balancing regular chemical reactions. What we're looking at here, you'll see again in Chem 112, and those will be more complicated redox or oxidation to reduction reactions. We're going to do some simple ones here in Chem 111 to give you a first step at it, a first taste of it. And the way we're going to balance oxidation reduction or redox reaction is called the half equation method or the half reaction method. What we're going to do is we're going to take this equation and break it apart into two half reactions or half equations, one for oxidation and one for reduction. You don't have to know up front which one is which. We're just going to break them apart. And when we do that, we're going to break them apart so that we have like species in each half reaction. So we're going to do an example in just a minute with the chromium and nickel. So one half reaction will involve chromium, the other half reaction will involve nickel. When we balance those half reactions, the sum of the charges on the reactant side has to equal the sum of the charges on the product side. And the only way we can balance those charges is by adding electrons. After we have both half reactions balanced, we're going to add them together. When we add them together, the number of electrons in each half reaction has to be the same. So that means we might have to multiply one or both of them by some sort of factor in order to get those electrons to be the same, because in the end, the electrons have to cancel out when we add the two half reactions together. There can be no electrons shown in the final answer. Let's do an example, see if all this now makes sense. The first one, we've got chromium solid plus nickel 2 ion reacting to make chromium 3 ion plus nickel solid. So my two half reactions. The first one is going to be chromium solid going to chromium 3 plus. And the other half reaction is going to be nickel 2 plus going to make nickel solid. So we want to balance each half reaction. The only way to do that in terms of charge is by adding electrons. So in the chromium half equation or half reaction, I've got chromium solid on the left. It's an element by itself. Its oxidation number is 0. So the chromium on the right-hand side, that plus 3, I've got to add something to that to make the product side wind up with a neutral charge. And the only way to do that is by adding 3 electrons. So it's 3 electrons plus a plus 3 charge from chromium gives me a 0 charge on the product side, which equals a charge on the reactant side. Look at nickel going from 2 plus to nickel solid. Once again, that oxidation number on nickel on the product side is 0 because it's an element by itself. And so the way to balance this half reaction is to add 2 electrons to the reactant side. So now we've got our two half reactions. Remember the mnemonic Leo, the lion goes grr. The first one, this is the chromium is on my oxidation half reaction. It's losing electrons. The nickel is gaining them. It's my reduction. So I want to add these two equations together. But when I do so, I've got to add them in such a way that the electrons cancel out. How can I do that? Well, let's take the first half reaction, the chromium half reaction, and let's multiply it by 2. So I've got 2 chromium solid, react to make 2 chromium 3 plus now 6 electrons. Then I have to take the second half reaction, half equation, involving nickel. To cancel out those 6 electrons, I need to multiply this equation all by 3. So I want to have 6 electrons plus 3 nickel 2 plus reacts to make nickel solid, and I've got 3 of those. Now if I add everything together, I'm going to have 6 electrons plus 2 chromium solid plus 3 nickel 2 plus on the reactant side. And I'm going to have 2 chromium 3 plus 3 nickel solid plus 6 electrons on the product side. So algebraically, I've got the same thing on both sides of the equation, and I got 6 electrons on both sides, so they cancel out. And so that leaves me with my overall reaction that says that 2 chromium solid plus 3 nickel 2 plus react to make 2 chromium 3 plus 3 nickel, this is solid. I need to check that it's balanced. You gotta have the same number of each type of atom on both the reactants and product side. I've got 2 chromium and 2 chromium. And I've got 3 nickel and 3 nickel, so my atoms are balanced. I need to check to make sure my charge is balanced. On the reactant side, I've got 3 nickel 2 plus, so that all adds up to plus 6. And on the product side, I've got 2 chromium 3 plus, 2 times 3 plus is plus 6. So it's important to note that the charges on either side don't have to all add up to 0. They don't have to be neutral, but they have to add up to the same charge on either side. They may well wind up being 0, but in this instance, they're not. So that's my first example. The next one, let's take iron solid plus copper 2 plus ion, reacting to make iron 2 plus ion plus copper solid. So my 2 half equations or half reactions. One of them is iron solid going to Fe2 plus, and the other one is copper 2 plus going to copper solid. I've got the same number of atoms on each type, so I don't have to do anything at this particular point, but I do need to balance the charges. For the iron half reaction, I've got 0 charge on the left because it's an atom by itself. It's